Hey folks, Mrs. White here. Today we're going to be taking a quiz that covers 3 sections of Chapter 5. So Section 5.1, which covers computing with functions. It also is going to cover Section 5.2, which was composition of functions, and 5.3, which was looking at inverse functions. So feel free to watch the whole little quick review, some of it or none of it. It's up to you. The quiz is attached to the classroom, so I'll show you how to access that in a second. To review adding, subtracting, multiplying, and dividing, we will just do this number 2. It has a higher degree, so it might be one that maybe is a little bit trickier. So let's start off by doing our first thing they're asking us, which is to do f plus g of x. So f plus g of x is going to have us add our 2 functions together. So we're going to take our x squared minus 5 and our negative x plus 8. And we're just going to combine like terms, which gives us x squared minus x plus 3. Okay. And I would just write this label in front of it and I'm done. Okay, all I have to do is combine like terms there. Not too bad. Next, I have f minus g of x. And that just has us do subtraction, which is one extra step. So I'm going to start with my f because that's what's listed first. X squared minus 5. And I'm going to subtract from it negative x plus 8. Now when I subtract, I need to remember to distribute that negative. So I actually have a plus x and a minus 8 that I'm going to be combining like terms with. So I end up with x squared, because there's no other squared term, plus x, and then negative 5 and negative 8 together, because now they're the same sign, is going to be a negative 13. And I'm done. I do need to add my label in front. F minus g of x equals x squared plus x minus 13. Next, I'm going to do multiplication. Multiplying, the order doesn't really matter. So to do f times g of x, I'm going to write my f first, x squared minus 5, and I'm going to multiply it by negative x plus 8. And when we multiply polynomials, we need to remember to be doing double distribution or triple distribution or however you want to think about it. So we're going to send this here and here. So I end up with negative x to the third, and then x squared times positive 8 is plus 8x squared. Then I'm going to send my negative 5 here and here, and I get positive 5x. And then negative 5 times 8 is minus 40. And then I should combine like terms. And looking here, it looks like I actually have no like terms to combine. So this will be my answer. I should put my label in front. Lastly, I have division. And I know this was kind of confusing for you folks because we just spent all this time doing long division and synthetic division with remainders. But with division and this stuff, if there's a remainder, we're just going to leave it as a fraction. So we are doing f divided by g of x. And in f divided by g of x, I'm going to have an x squared minus 5 up top. And I'm going to have a negative x plus 8 below. This does have a higher power, so I could try to divide them. But I can already recognize negative x plus 8 is not going to be a factor of this. If I was thinking of simplifying this without having to do division, I would say, okay, this is a difference. This is a perfect square, and this would have to be a perfect square. It'd have to be a difference of 2 squares for me to be able to divide a factor out of it. And it's not right now. So I'm going to just leave this right now as is. Okay, so that just covered adding, subtracting, multiplying, dividing. You're also going to see on there a couple straight up composition ones, and I want to remind you that composition has this little open circle, okay? So it's like the fog-off problems. And what we do here is we take one function, so this will take the g of 4, and plug it into the f function, whatever outcome we get there. And you could see a question where it's like this, where you're plugging in a constant, or where you're plugging an actual function into another function, okay, which is what we're going to be doing in these because they don't give us an x value to use. They're telling us do f of g of x. Here we're doing f of g of 4. So I'm going to start by plugging 4 into my g function and simplifying. So if I plug a 4 in here, I would have 2 times 4 is 8. 8 minus 10 is negative 2. So now I'm going to take that and I'm going to plug that negative 2 into the f function. So negative 2 squared is 4. 4 plus 3 is 7. So I end up getting that f of g of 4 is going to be 7. My pen is not working today for some reason, so I'm sorry. Maybe it needs some new batteries. I'll check it out and try to improve it next time, but for today's video, we're just going to have to bear with me. Next, we have g of f of 4, so that means we're going to do f of 4 first. So I'm going to take 4, and I'm going to plug it into my f function. So 4 squared is 16, 17, 18, 19. So now I'm going to do g of 19 equals, I'm going to take 19, plug it into my g function. So 2 times 19 is 28. 28 minus 10 is 18. So I get that g of f of 4 is going to equal 18. If we come down here, okay, these are a little bit harder composition of functions, and this is the same stuff we use when we're doing inverses, okay, but we want things to cancel with inverses. When we're doing just straight up compositions, we need to kind of slow our roll a little bit and double check our domains and ranges. So let's look at 13 because again it has higher power, so it could be a little bit trickier. We're going to start off by doing f of g of x. Okay, so f of g of x is going to take our f function, and we're going to plug g of x into our f function, and then simplify. So we're going to take this and just plug it into our f function, which honestly, if you look, we just have x plus 4. It's just going to be this plus 4. So that's pretty easy. It's going to be x squared plus 3x minus 10 plus 4. Again, because I just plugged it in. The only simplifying is going to be combining like terms with this and this. So I'm going to end up with x squared plus 3x minus 6. Now we should check our domain and range for these. Our domain here is all reals, okay, and our range is also all reals. So when we solve this and we get all reals as our answer, we need to make sure that we can plug in all reals here, right? Because what we did is we found our answer and we plugged it in to the f function. So, excuse me, I'm sorry. I have to say that. I said that wrong. I'll say that again in the correct way. So we have g of x, this one that we're plugging in here. So since we have this, we want the outcome of this to work for the input of this. So the input of this is all reals anyways. So if our output is going to be that it's smiling, but it's going to have some movement to it, that it's still going to work here because the range here is going to be greater than some number, but the domain here is all reals, so it doesn't matter. Okay, if we were to check if it's going to exist, it is going to exist. The domain and range for something like this, we would actually have to graph. I am not going to ask you to do domain and range on that quiz, so don't worry about it. Let's do g of f of x now. So I'm going to take my f function, I'm going to plug it in my g function. And this one is clearly going to be a lot more work because I'm taking this and I'm plugging it in here, and I'm plugging it in here. So I'm going to have x plus 4 squared plus 3 times x plus 4 minus 10. So x plus 4 squared, I have kind of that shortcut for if I times something by itself. You could just do double distribution. It is going to end up being x squared plus 8x plus 16. This I can distribute across. It's going to become a plus 3x plus 12. And then I'm going to just bring down my minus 10. I'm going to go highest to lowest power, so it's x squared. Then I have 8x and 3x for a positive 11x. I have 16 plus 12, which is 28. 28 minus 10 is positive 18. And this is my answer for the second one. Okay. And I'd have to graph it to figure out the domain and range. Okay. All right. So now let's talk about our last topic. I'm trying to keep this quick, which is looking at doing the inverses. First, finding inverses, writing inverses, and then determining if they are inverses. So to find the inverse of a relation, which is just a set of ordered pairs, you literally just flip-flop your x and your y. So it's very, very quick and easy. If you start with 3, you're definitely going to end with 3 if you're doing an inverse, not a composition, okay, an inverse. I'm going to flip-flop my 6 and my 8, so it's going to give me 6 comma negative 8. I'm going to flip-flop my negative 2 and my 6, so I'm going to have a negative 2 comma 6. And then I'm going to flip-flop my negative 3 and 7, so negative 3 and 7. And that's the answer to the inverse of this relation. To find the inverse of a function, you're going to start by kind of plugging your y back in there, and then you're going to replace your x and your y with each other, kind of flip-flop their positions. So I'll have an x equals negative 8, y plus 9. I'm going to rearrange this so that my y is alone and positive, and I'd be ready to graph it. So I'm going to minus 9, and then I'm going to divide by negative 8. And that's going to give me my y alone and positive. So you could keep it like this. If you were asked to graph it, you would obviously want to have negative 1/8 x, and then negative over negative is a positive, 9/8 equals y. I'm okay with either answer. If you're going to graph it, obviously this one makes more sense though. So let's take a look at our last little bit of review here before we look at what the quiz is going to look like when you access it. Determine whether each pair of functions are or are not inverses of each other. So the way that you do that, and again, we'll go with one that's a little bit funkier, okay, is you're going to do your composition of functions. You're going to do f of g of x, and you're going to do g of f of x, and see if they cancel out to be just x, which is our identity function, that y would equal x. And so we're going to do that. So we'll start off by checking f of g of x. So I'm going to take my g of x and plug it into my f of x. So I'm going to take this chunk and I'm going to put it in here. So I'm going to have 2 square root, instead of x, I'm going to plug in 1/4 x squared minus 5, and then a minus 5 on the outside. So I could start by taking these parentheses off right now because we're just subtracting. And then I'm going to see I have a minus 5 and a minus 5. Are those going to cancel each other out? The answer is no. So I can automatically see that this is not going to become just x, because negative 5 minus 5 is going to give me a negative 10. Okay, so I can stop right now and say that no, these are not inverses. Let's take a look at this one. Maybe this one is, and we can just do a little bit more work to see how that pans out for us. So let's do f of g of x here. So I'm going to take my f function, I'm going to plug g of x into it. So I start off with 4x, so it's going to be 4 times x minus 6 over 4, and then a plus 6 here. So these two things cancel, right? I multiply and divide. I'm left with x minus 6 plus 6. These two cancel. I do get x. Next, I'm going to check my other composition, g of f of x. And again, I have to get this on both for it to work. I'm going to take this function and plug it in right here. So I'm going to have, instead of x minus 6, I'm going to have 4x plus 6 minus 6, right? I just plugged this in, all over 4. So plus and minuses cancel. 4x over 4 is just x. So yes, these two are inverses because both of their compositions equal only x. So after you're feeling good about this, folks, and feel free to go back, look over your homework, look over previous videos. I want you guys to do good on this quiz. You're going to go back into the classroom. Okay, you're going to go down to where you access today's videos, right? And you're going to click on mid-chapter quiz, and it's going to load this up. Okay, now what you have here is 7 multiple choice problems. Each one's worth only 1 point. Okay, and so you should try your best on those, but there's no partial credit, so it's either right or it's wrong. So don't stress out too much about that. At the very bottom, and this is why we're going over these directions, the last few problems, and I don't really want to show you them right now. Why isn't this working? There we go. Okay, the last few problems here are going to require that you do them on Scrap. Okay, oh, that's fun. We'll just full screen this thing. Okay, so you're going to go back, you're going to do them on Scrap, and then you're going to add the file. Okay, so you'll solve 8, solve 9, solve 10, solve 11, solve 12. If you want to, you can take a screenshot of this and print it off, but you certainly don't have to. Make sure you're following the directions. If you look there, 1, 2, 3, 4, 5 problems. Each one is worth 5 points. So if we're talking about making sure you really take your time, these 5 are partial credit, and they're worth the majority of the points because this whole thing's only worth 32. Okay, so you'll add your file, you'll attach it, and then you'll click submit. Okay, you need to have this done by midnight tonight. So we're talking about today is the 6th. Yeah. Okay, so you have to have it done by midnight tonight, April 6th. I will see y'all later. I am not holding office hours tomorrow. I'm going to use that time to do some grading. Okay? Thank you, folks. See you later. Bye.